very good morning to everyone. I'm Kuldeep Rastogi and I'm standing here to take your signals and system. This subject is particularly very important for competitive examinations, namely GATE, UPSC, ESE and PSUs and other state engineering services exams also. Now I shall be taking this subject with the mainline requirements of your competitive examinations only. Nonetheless, the subject is very good and simple for competitive exams also, but it will also provide you a basic baseline to understand your core subjects like communication systems and control systems too. So to begin with, I must introduce you with the kind of syllabus, and one more important point is that I have framed this syllabus by keeping in the needs of all of your examinations. So let me introduce you with what are the points, what are the outlines we will be discussing in the next coming sessions of this lecture series. So to begin with, let me take you to the syllabus kinds of things. The syllabus would be, number one, definitely introduction part. That is introduction to signals and systems. Thereafter, we have to discuss LTI systems. LTI stands for linear time invariant systems and convolution procedures. What are they? We will discuss in the coming sessions. Number three would be Fourier series analysis. Then we have to move towards the transforms. That is actually very important. I shall begin with Fourier transforms and its applications. Then we will be discussing Laplace transforms and applications. Then we have the next transform, which is Z transforms, and the last would be the sampling theorem. One more important point, recently GATE has added, and also in UPSC, these questions are often asked in examination that are particularly from digital filter design. So I would also take that particular topic in this lecture series. This should be digital filters design. So these are the 7 to 8 topics I would be describing briefly over here. Now I shall continue with the first topic, which is introduction part. What is called signal and what are the articulates in which we have to study the signal and apply that signal for the understanding of the entity called as systems. So to begin with, I must take signals at first place. After discussion of signals, we have to move on to systems only. So, the basic fundamental question in front of you people is, what are the things you may call as a signal? And there are few points you must remember to understand signal. It's a form of energy, first point. It should be an entity, a thing that has some associated information in it. Now that information point is actually very important, because if you're not getting anything from the point of something, from the point of energy, that energy would not be called as signal. It's just an energy format then. Those energy formats which are able to communicate with me or you, which are able to let me understand something from that is the piece of information. So information content should be there. That form of energy would I call as a signal. Now if you're getting that A signal would be an entity which is having some associated information. Then you might be having a question that what will I do with the information? The answer to this question is that signaling is required to understand the behavioral pattern of some phenomena which has recently occurred or has occurred sometimes, or I would predicting to be occur. So that information of a particular physical or natural phenomena, their behavioral patterns, in which pattern the quantity has changed its values, that behavioral pattern of a quantity would be termed as a signal. And because the phenomena has occurred with some variations with a variable quantity, that is why a variable quantity is required to express the variations in that information. So I must need a variable. So mathematically, a signal can be represented as a mathematical function. Nonetheless, it's very good to understand signal as a mathematical entity, but actually the signal is not only the mathematics of the particular phenomena or the variation. You must understand that the signal which you are taking into your account must be communicated. Communication is the main purpose. That is why you are studying signals in your undergraduate course in 3rd semester or 4th semester, in the very basic part of your signal. When you start engineering, that particular part would be in 3rd or 4th semester, and communication comes later on, because you have to apply that knowledge of signal onto the understanding of communication systems. So I must summarize what I have just said, that suppose if I'm giving you an example, if I'm moving my hand in this way, it means that you're getting an information that come here. Sir is moving his hand in this manner. It means sir want to communicate with us. Sir has been giving us an information by this gesture that please come towards me. And if I'm moving my hand in this way, in the opposite direction, then you have got an information. If you are a human being, you must get an information that now sir is saying something else. So there are two pieces of information I have just been given to you just by movement of my hand. And suppose because I'm moving my hand, it's a form of energy, because it requires some energy, so I'm doing it. Energy would be there. I'm doing this, energy would be there. You are getting some information that by this come inside or come to me, by this come away from me, you have to go away from me. But if I'm moving my hand in this and this manner regularly, or if I'm doing something arbit, then you won't get any information. But I have moved my hand, so I have definitely did some work, and definitely there was a piece of energy that should be applied to doing these things. Now because energy would be there, but you have not got any information extracted from these kinds of gestures, it simply means that you have not got.
If you really like the video, please hit the like button, share the video, subscribe to our YouTube channel and press the bell icon for the latest updates. Thank you.